The last thing in Notes 13 is an example to give us some practice going through an entire problem from beginning to end. So I've got some data for you in SAS On Demand that is from a survey that was given to 208 Elon students in the fall of 2012. And this survey had a whole bunch of questions about different aspects of health, mental health, physical health, everything. The actual full data set includes over 100 variables. I don't remember exactly how many. But for now, we're just going to focus on one of those variables, which was a question where students were asked if they had received information about stress reduction. And I've got two files on SAS On Demand, one that shows you what the data set looks like as counts, and one that shows you what the data set looks like as raw data. And our goal is going to be to determine if there is enough evidence for Elon to claim that more than 50% of all students have received information on stress reduction. So we're going to set up some hypotheses for this question. You can see that this 50% number is here, so my null model is going to say p equals 0.5, which would mean that 50% or half of all Elon students received information about stress reduction. And if Elon wants to be able to claim that more than 50% have received this information, our alternative hypothesis needs to reflect that. So our alternative theory is that p is greater than 0.5. All right? So I'm going to go to the data in SAS, and I'll show you first as counts. You can see that 115 people said yes, they had received information. 91 people said no, they hadn't. And we can talk about what this .2 part means a little bit later. So stress is my first variable, what categories people fell into, and then count how many people were in each of those categories. As raw data, I would just have my single variable, which was stress, and I would just have a list of each person's answer. So yes, no, yes, 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 no, 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 and so on. All right? So let's use the counts one for now, just because then we can see all of the code here. And what we're going to do is we're going to run the data and the frequency part. And you'll notice that ours does include a line that starts with the word wait. And the reason why is that we need to tell SAS not just what variable includes the yes or no responses, but we also need SAS to know how many people had each of those. So we need to tell SAS that the variable categories are weighted by how many people show up in this count variable. So let me select everything and run it. And what you'll see is I didn't have all of the code that I mentioned before where it said like slash, binomial, stuff like that, because we can use this format to just give us a simple table telling us how many people were in each category, along with percentages and things like that. So one thing to point out is that even though my data said yes and then no, SAS put the no answers first, because remember, SAS likes to put things in alphabetical order, so I would want to be careful when I was reading this table to note that. But I had 91 people say no, 115 people say yes, and then this says frequency missing. So this is actually because 2 people chose not to answer that question in the survey, and so we didn't have information from them. So I could fill in my table here, all right, and this is what I would get. And the first thing I might look at is say, well, Elon wants to say more than 50% of all students received information about stress reduction. At the very least, it looks like more than 50% of our sample said they received information. So it seems plausible that more than half of all students have received this information. But just like we've been going through with some other problems, there's 2 possible reasons that we could see a result like this. One reason is that the population proportion is really above 0.5, and our data is a reflection of that. But we still can't rule out this second option, which is that maybe the population proportion is actually 0.5, or really even lower, and it was just random chance that our sample saw about 56% of people saying yes. So we need to investigate this further. That's what everything we're doing in statistics is really, is we're saying, did we see this because of random chance alone? Or does it really represent something real something about our population that Elon can then communicate to others. All right, so we are going to add some other stuff to our code. I'm going to add this part that adds binomial. I want to test a null model that says p equals 0.5. I'm interested in studying the people who say yes. And maybe I'll make a 95% interval and tell SAS to calculate some graphs along with this. So let me try actually opening a new window here real quick. And it took out all of my spaces, or at least on that first line, so I'll need to add those back in. Let me try running this. And you can see that I've still got that table. I've also got a graph now showing me how many yeses and how many nos I had. And then I've got a bunch of information here that we're going to use to fill in what's on the next page. If you haven't had a chance yet to work through this example on your own, please pause the video, try all of these questions that follow on your own, and then come back to check your answers. You want to be able to get a chance to try some of this without seeing all of the answers ahead of time, so you know which parts are making sense and which parts aren't. All right, so let me first show you what the different output means. All right, the first line you'll see, it just says proportion, and you hopefully notice that this is our sample proportion. All right, we'll ignore this next part here and instead focus on where it says 95% lower conf limit, 95% upper conf limit. That's going to be our 95% confidence interval. You might have also noticed that this looks pretty similar. Your numbers are a little different. We're going to ignore this section for now. It's just a different way of finding a confidence interval. So it's not the method that we used, so we'll use these numbers when I ask you for a confidence interval. And then we can look down to see about our hypothesis test as well. If we calculate our test statistic, this is the number that we get. And then we never actually specified anything about our alternative hypothesis. So what SAS does is it gives us one one-sided p-value and one two-sided p-value. All right? So the two-sided p-value, that's just going to be plugging 1.6722 onto my horizontal axis, also putting negative 1.6722 on there, and then shading on both sides. So that would be if we had an alternative hypothesis that said p was not 0.5. But we know that there's actually two possible one-sided p-values, so we need to be a little bit careful here. SAS will actually give us whichever one of these one-sided p-values is smaller. So in this case, you notice that there's a greater than sign here, but it's actually possible to also get a less than sign. And so we would want to look at what our actual hypotheses are. So for us, we had an alternative that said p was greater than 0.5. So this actually does match up with what we want. And we could verify it by putting our test statistic into StatKey, shading everything above that, and you'll notice that I also get 0.047. On the other hand, if I had a less than sign in my alternative hypothesis, what I would really want was this whole unshaded area here, and I could either just shade that on StatKey, or I could take 1 minus the 0.047 and figure out that this p-value for an alternative that said p was less than 0.5 would be 0.935. All right, so if you watched this before doing the questions that follow, again, I recommend pausing the video, using this information here to try the questions that follow, but I'm going to go through them now, so whenever you get your answers and want to check them, you can watch the remainder of this video. So first, we found the test statistic already. We said it's this z value here, but we might want to verify it through the calculation. So we could plug in our sample proportion, p hat. We can plug in the p from our null hypothesis, and we can plug in our sample size, which is the 206 people that answered our question, and you can see that you get the same number if you did this by hand. So that's good. We can verify what SAS gave us. We could also try to verify the p-value. And so we could go to stat key, we could choose normal, we could click on right tail because we had a greater than sign for our alternative hypothesis. And then we could put our test statistic on the bottom, and we'd get our p-value of 0.047. All right, so if we wanted to take that and write a conclusion, our p-value is less than 0.05, which means that if the null hypothesis is true, this would actually be kind of an unusual thing to see. So what we've said is that in these cases, this serves as sufficient evidence that our alternative hypothesis is true instead. So I would say, since my p-value is below 0.05, there is sufficient evidence that the population proportion of Elon students who received information about stress reduction is bigger than 0.5. Basically, I'm saying more than 50% of all Elon students received information about stress reduction. And the reason is that even though I only looked at 206 Elon students, this would have been a pretty unusual sample if only 50% of students had heard this information. So that means that I feel confident claiming that more than 50% of all students received this information. So that's how we would do a hypothesis test. We've got our hypotheses, our test statistic, our p-value, and our conclusion. We could supplement this with a confidence interval, or take a slightly different approach to answering a question about what proportion of students had received this information. I found this information in the SAS output. We said that we're going to use this part here in the first section. So my confidence interval is from 0.49 up to about 0.63. If I wanted to interpret that, I would say we are 95% confident that between 49.04% and 62.61% of all Elon students received information about stress reduction. So we wanted to know if we could say that more than 50% of students received this information. What we were able to find with this interval is that we think that actually it could be as high as almost 63% of students received it, or it could be as low as only 49% received it. And some of you may be wondering why our interval contains 0.5 or 50% if we said that we had sufficient evidence that the population proportion was actually above 0.5. And the short answer for that is basically that we tested a one-sided hypothesis. Our confidence interval is necessarily two sides. We've got a lower and an upper bound. And so our answers aren't always going to perfectly match up. You may have noticed that if we looked at our two-sided p-value, that actually was above 0.05. And so in that case, this would have matched up with our confidence interval, where we said, well, 50% is a reasonable thing that could be true for the population. And so don't worry too much that our answers are sort of slightly not matching up here. They both seem to indicate that, even if it wasn't more than 50%, it was pretty darn close, and could be as high as 60% or more of students that received this information. So this wraps up our look into how we would handle a single qualitative variable and answer questions about population proportions. In the next set of notes, we'll see how we can answer questions related to two qualitative variables and whether or not they're related to one another or associated with one another. But what I would recommend for Notes 13 is find some other examples, do some practice problems, but also look back at some of the questions related to one sample problems for population means, and you'll notice that there's a lot of similarities there.